Okay. Chapter 2, Level M Chemistry. This is about all the tests, solubility rules, والقرف. Let's start. Okay. Solution has this and this. PbNO3, BnO3. Which of the following is added to remove Pb without removing barium? So when you want to remove something, basically they're asking, something that forms a precipitate with it. Okay. The only things that form a precipitate with Pb, if you go back to our solubility rules, over here with the ClBr and I, Pb will, it's not soluble, meaning it will form a precipitate. So anything that has ClBr and I would work here, and the only one that does is NaBr. Okay. Question 2, the solubility. Okay, this is the first time we solve a question on this channel, even though it was supposed to be in the AMS last week, but she didn't get any solubility questions. To do with solubility. Solubility is very, very easy. It might look complicated. People get scared. They're seeing temperature. Solubility is the amount of solute that can dissolve in a solvent at a specific temperature. Here, they said that the solubility of barium nitrate at 60 degrees is 20 grams per 100 grams. And then they said at 100 degrees, it's 32 grams per 100 grams. What mass will form if 300 grams of saturated aqueous solution, so this here is 300, okay, is cooled from 100 degrees to 60 degrees. أول شيء, if you're cooling from 100 degrees to 60 degrees, how much, you guys know, like, to help understand this, if I have 50 degrees, when I mix sugar with water, it's gonna dissolve, right? But let's say I add more, the sugar will either float to the top or sink to the bottom. Like, there will be some leftover sugar, right? Not all of it will dissolve. What if I heat it up now to 100 degrees? Now all the sugar will dissolve, right? Here there'll be like some left over. Here now all of it will dissolve. So because I increase the temperature. What happens if you go back and you cool this temperature back down to 50? It's going to go back and these sugar molecules will, will undissolve and turn back into whatever, precipitate. So my point here is what they're saying. It was at 100 and they went back to 20. They went back to 60 degrees. How much are you going to lose? At 100, 32 grams dissolve. At 60, 20 grams dissolve. So that means 12 grams will form. But are they dissolving it in 100 or 300? In 300. So what do I have to do? I have to multiply by 3. Okay, so 12, 3 times 12, 36 grams. If you want an easy way to do this, okay, you can write it like this, okay? For those of you who like these straightforward methods, you're losing 12 grams. When you're cooling, you're losing 12 grams per 100 grams. And I want to know how many grams I'm losing per 300 grams. And if you cross multiply, you're going to get the same thing, 36, okay? Whatever you want. 3. A group of students, okay, they're testing Ki. Okay, how would you test the presence of I minus? These are the easiest ones. Obviously, you add AgNO3, and if you add AgNO3, it's going to form a precipitate AgI, which is yellow, because iodine forms yellow, right? Which of the following can be used to test the presence of K+? K+, you use the flame test, right? You dip a platinum wire in the solution, you put it in a blue flame. People say, "Shoo blue flame, yeah, the color of the flame originally is blue." Okay? What happens if you put potassium in a blue flame? You're gonna get a lilac violet flame, right? Very, very straightforward questions for now. 4, you have this ammonium chloride and calcium nitrate. Which of the following would precipitate with Cl-? Again, what's the test for Cl-? It's always AgNO3, and you would get a white precipitate. Very easy. Hala, for Ca2+. Remember, from the AMS video, you have the table calzone, right? This is 2+, 3+, it's 2+. Okay, and we know that up you have NaOH, and here you have NH3, right? Calzone, NaOH, NH3. Remember we said calcium is insoluble and it has no reaction. Then here you push it to the right, so it becomes insoluble over here. And whenever you have an empty space, you just put soluble. And you push it to the right, so you're going to have soluble here. And you have an empty space, so you put soluble. This was the table we had. So to test for Ca2+, you can dissolve it in NaOH, and you will see that the precipitate will form that is insoluble in calcium, as in NaOH. All of these precipitates are white, by the way, huh? All of them. Okay, so أكيد NaOH will work. Why is Na2CO3 correct? This wasn't in any of my notes, but it came in the AMS, so I got it wrong. What happens when you dissolve Ca2+ and Na2CO3? The Ca2+ will mix with the CO3 2-, and you're gonna get a shoe equal. You're gonna get No, this is single arrow. CaCO3 solid. Okay, this is a precipitate that does not dissolve. This doesn't dissolve in water, but because this was an AMS question, yeah, but it dissolves in acid. In the AMS, they said HCl. Okay, just important to know. These akid no, we don't care, but in general, Ca2 plus use NaOH, but you can also use Na2CO3. Okay, how would you know if it's Na2? If you add Na2CO3, it's gonna form a white precipitate CaCO3 that does not dissolve in acid. Okay, sorry, that does dissolve in acid. That does dissolve in acid. The one that does not dissolve, in acid, I actually wrote it over here. Yeah, here. Okay, can I zoom in? Yes. Okay, the ones that don't dissolve. Okay, because I was writing this for SO4 minus. When you add barium, you get BaSO4, which is a white precipitate. But في عندنا كتير white precipitates. You have white precipitates with CO3, SO4, SO3, whatever. Okay, I know here I'm saying I'm adding Ba2 plus, but also if you add Ca2 plus, these also work. Okay, if you add Ca2 plus to CO3, you're gonna get CaCO3. If you add Ca2 plus to SO4, you get CaSO4. And same thing. Okay, you could say Ca/B. Okay, so in this table, basically what I'm saying is you're going to get a white precipitate when you add barium or calcium to CO3, SO4, and SO3. But the only way you'd know that it's SO4, if you get a white precipitate, is if you dissolve it in acid. If it doesn't dissolve, it's insoluble in the acid, yeah, and it's SO4. It was part of the notes. You know, I'm not just saying this. Hey, I'm not trying to confuse it. It's like the regional, she gets stuff from the notes that aren't in the quiz a lot of the times. Okay, if you mix this with this, what's the net ionic? Whenever they say net ionic, then they want precipitate. And when they say precipitate, and it doesn't dissolve. Because sometimes it's gonna form a precipitate that does dissolve. We don't care if it doesn't dissolve. Okay, we only care if it we don't care if the precipitate dissolves. Because then it won't really be a precipitate, it will be dissolved, right? Now we care if it doesn't dissolve. Like that's when you would actually see the precipitate. So what's the precipitate here? Let's see. To form a precipitate, أول شيء you can do it like you can do crisscross, the way our teacher told us. Okay, you put them above each other, and you crisscross NaNO3 and CaCO3. أكيد هاي it's gonna be شو اسمه Na plus NO3. Yeah, these are your two things. But let's see here. Which one here doesn't dissolve? We know Na dissolve because it's part of the big five. And I said big six in my MS question, in my MS quiz. بالغلط. I meant to say big five. I miscounted. But it's part of the big five, so it always dissolves, right? And then we said CaCO3 from the last one. It doesn't dissolve. In general, when you say it doesn't dissolve, we're talking about water. Unless you say it doesn't dissolve in acid, that's when you're actually talking about acid. But if you just say something dissolves, something doesn't dissolve, that means you're talking about water. Okay. Okay, anyway, they're not asking for the precipitate, they're asking, write the net ionic equation. Let's see. How do you write net ionic? Net ionic, you just split it up into ions. So you have Ca, you have CO3. Okay, you're gonna say, Walid, oh shit, man, I don't know what the charges are. I'm gonna tell you, okay, well, obviously it's multiple choice. That's the first thing. Okay, to form CaCO3. The first thing is it's multiple choice. In case it doesn't come multiple choice, like I told you, I think in chapter 1 quiz, over here in your original compound, you know that when you crisscross originally, the subscript of this was the charge of this, right? So this 2, it went down to become the subscript of the NO3, okay? So this calcium, it's what? It's 2. Okay, since it's a metal, it's plus. Also, if it's the first one, it's akid is a positive one. But then CO3, the charge of CO3 would be what the subscript of Na is, right? So you just take it back up, and CO3 2. Okay, أكيد it's minus. The precipitate never has a charge. وأكيد the precipitate, the state of it will be solid. هوري دايما always the charges or the ions are aqueous. Okay. What's the color of the precipitate that forms? We said CaCO3 is white. Okay. Calcium carbonate. Nothing else. I'm gonna go through these a bit quicker, even though you can't really speed up on it. But yeah. Okay, soluble or insoluble. It has sodium. Remember, big five. What are the big five? Na, K, NH4, NO3, CH3, COO. Was it CH3COO or CH3COH? It was a COO, right? Yeah. Okay. أكيد عندهم charge minus plus. Okay. Anything that has these are always soluble. This one has an A, so soluble. Oh, I shouldn't do that. Okay, we're done. AgCl, we know Cl is always soluble. Cl, Br, and I are always soluble except with Ag and except with Ba. No, should be A. Except with the Ag and Bb. Here it has Ag, so أكيد it will be insoluble. BaSO4. SO4 is soluble except with barium, except with lead. Pb. It was here, I think. SO4 insoluble except with barium, calcium, and Pb. Okay. So since it has barium, insoluble. Kf, it has K, soluble. PbCl2. Again, Cl when it has Pb, insoluble. Yeah. BaNO3. Okay. Anything that has NO3, we said it's soluble. Okay. I'm not gonna erase these because I think there's another question that's also matching. I'll keep this on the side. I'll take it up. Okay. A few drops of NaOH were added. Okay. The solution showed blue suspension. Don't even waste your time. What's the ion? Cu2 plus. Copper. Copper is Cu. Guys, if you don't know what the formula of it is, go to your periodic table, check what's copper. You'll see copper is Cu, which charge is 2 plus. Okay. You can get this from a different question. There is question 8. Okay. So we have a metal, NO3. Okay. A few milliliters of the following solution is added to the MnO3. So they added sodium chloride, nothing happened. They added K2SO4 and you got a solid precipitate. They added HCl, the solution stayed colorless. Okay, then they added Na2CO3 and you got a solid precipitate. For me, and what gave it away is the Na2CO3. The only thing that forms something with Na2CO3 is calcium. Okay, always. واكيد هون they meant to know if calcium, wait, yeah, calcium with SO4. If you add from here, we said if you add to SO4 barium or calcium, you're gonna get a white precipitate, right? Okay. 9. Okay. So basically, they said some anions they react with acids. La 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 la. Check the boxes where the observation is relevant. Okay. أول شيء NO3 you don't react it with HCl. Okay. That's the first thing. We don't react it with an acid. NO3 you add sodium hydroxide and you add aluminium to form an H3. Okay. That's a different thing. So we're adding a base here. So we don't care about HCl. So that's why for the first one, we didn't tick any boxes. CO3 2 minus, the carbonate. Carbonate, we add an acid. Okay, and when you add an acid for CO3 2 minus, you add any acid. Whenever you're adding an acid, by the way, we represent it by H plus. Okay, you get, remember we said CO2 gas, and I think it was water, but we don't care about the water. What we care is about the carbon dioxide. Effervescence occurs. أكيد. Gas released is acidic. Carbon dioxide is slightly acidic. Okay, it was in the notes. You'll find it. Trust me. So carbon dioxide is slightly acidic. Okay, effervescence, by the way, means a gas is released. And there's bubbling. Effervescence is kind of like bubbling. Gas release has a choking smell. No, carbon dioxide doesn't choke. Okay, it's عادي gas عادي. How about SO3? SO3 2 minus follows the same test. You add an acid كمان. Okay, or you get SO2 gas. كمان water. I won't write. But SO2 gas, it's characterized by أكيد effervescence because you're forming a gas. Effervescence is whenever you form a gas and there's bubbling. Gas release is acidic. Yes, SO2 is acidic because it turns litmus paper red. Okay, has a choking smell. Yes, SO2 has a choking smell. وكمان it also, if I'm not wrong, it reduces the color. Let me check. Yeah, it also SO2. It's written here. It reduces the color of potassium manganate from purple to colorless. If they say it يعني. Okay, 10. Okay, this is very easy. Bromide, kid Br is creamy, Cl is white, I is yellow. These are easy. Okay, this one, color of the flame, we know. Crimson red. This isn't brick red. Brick red, I'll show you what brick red looks like. Okay, honestly, this is the best picture I could find. For lithium, it's crimson red. Okay, this is how it looks. And it's more of a dark red. But we're not responsible for this one here. But for calcium, it's brick red. Okay, brick red, it's like this. You know what I mean? It's like red, but it's more orange. Brick red is kind of like orange red, if you get what I'm trying to say. Okay, it's because some people they will get confused about it. But the reason she won't get this type of question where it's both of them. Here also there's no choice for calcium. بس هيك. Anyway, so crimson red we know it's lithium. This isn't brick red. This is obviously yellow, right? It's lithium. شو lithium قصدي sodium. وهيدي it's kind of turning purple. It would be potassium. It would be if it was blue يعني مبيني blue that would be copper. Okay. 12. Okay, few drops of barium nitrate are added to an unknown solution. A white precipitate X forms and does not dissolve in acid. I'm going to continue reading later because obviously they want precipitate X. Okay, if you're adding BaNO3 and you get a white precipitate X, when you add barium to something, you're getting a precipitate. What is it? We know barium sulfate gives me a white precipitate, right? So BaSO4. It's حفظ. I can't really tell you anything other than memorize. When you add barium, specifically acidified barium, if you go here and you go to SO4, it's acidified barium nitrate. Okay, you should memorize it. When you're adding barium nitrate, you're usually testing for SO4 and you get a white precipitate. So BaSO4. Done. Hella, continue. Few drops of sodium hydroxide NaOH are then added to the unknown solution. You get a dirty green or green precipitate, whatever, that is insoluble in excess NaOH. This is very important. We know if it's green, it's either Fe2 plus or Cr. I think it was Cr something. See, I don't know the charge. But anyway, I think 3 plus. Was it 3 plus? Yeah, 3 plus. So it's either one of these. But what did they said? They said it's insoluble, right? If something's if it's insoluble, yani we want iron. Okay, Fe. What's the precipitate? Okay, this is like some people get this wrong. Enter you have Fe2 plus. When you're reacting it with the base, akid is gonna mix with the OH. OH is OH minus. So OH minus. Do crisscross, you're gonna get Fe. Then this 2 is gonna go down here. But you know when it's like more than one, you have to put it in brackets and then put the 2 outside. Right? Okay. Give the chemical formula of the unknown solution. So this solution, we found out what? We found out our sheet contained SO4 from adding the from getting the white precipitate. Then we found out it contains Fe. Right? So what is the formula? It's FeSO4. ما بدها هالقد. Question 13. Anna prepared a solution having copper sulfate and ammonium chloride. Upon adding a few drops, a blue precipitate forms. Choose the correct answer to the solution. Okay. True. Anyway, what did you add to get a blue precipitate? نحن we know blue يعني copper. Cu2 plus. Right? نحن we have Cu2 plus. Enta when you want to test for Cu2 plus, you have to add NaOH or NH3. But NH3 wasn't in the choices, only NaOH was. So that's why the answer is NaOH. When you want to test for this Cu, what do you add? You add a base. Yeah, NH3. Yeah, NaOH. Okay. Here we want to know if it's a molecule or an ion. I2, akid, it's I. Usually when you have two يعني ورا بعض, it's a molecule. No, usually. FeNO3, this is an ion. Akid, you have nitrate ions and iron ions. C6H12O6, akid, it's a molecule. It's, Akid, by the way, you guys know if something's an ion or a molecule, it's if ion is metal and non-metal, molecule is non-metal. Okay, I2 is non-metal فأكيد molecule. This is metal non-metal فأكيد it's an ion. This is كلها non-metals ف molecule. HCl, people are going to be like, this is non-metal, why is it ions? Because it's an acid. Okay, acids dissociate. Well, it's chapter 3 chem, but you should know this. Acids are electrolytes, meaning they dissociate. And this came in the AMS. People were like, whoa, what's an electrolyte? An electrolyte is any compound that dissociates in water to form a conducting solution that can conduct electricity. Okay, HCl is an electrolyte. It's an acid. Most acids, or I think all of acids, dissociate to form conducting solutions in electricity. Okay, but acids are not ionic compounds. They're molecular compounds, but there are some molecular compounds that we call electrolytes No, electrolytes aren't only molecular. Like in general, there are some molecular compounds that, even though they're molecules, they dissolve in water to form to form ionic solutions. Okay, and those are, part of them is acid and bases, some bases. Anyway, NaNO3, أكيد you have Na plus, NO3 minus ion, metal, non-metal. Which of the following substances are electrolytes? Electrolyte is anything that forms ions. That's it. Forms ions. And to form ion, it doesn't necessarily mean it's an ionic compound. It can be ionic or molecular, because that was the question in the CA. Done here. 15. Okay, you have nickel, silver, copper, and aluminium. They added HCl. What is the precipitate that forms? Okay, let's see here. So you have HCl. Akid H won't form anything with here because they're all pluses. So the minus, we have the Cl minus is going to form with it. Did we say anything about Cl and nickel? No. Cl and Ag? Akid yes. AgCl, which is silver chloride, which is white. 16. Okay, this one, it confused me at first, but no, I was like, after I got it, it made sense. So you have a solution that's containing chlorine, carbonate, nitrate. Okay, when you add calcium, it can be a solution or it could be a precipitate. When you add calcium to which one here do you get a precipitate? Okay, this is minus minus. Oh no, they're all minus. Yeah, when you add calcium to chlorine, CaCl, it doesn't do anything. Also, it's not in the choices. CaNO3 we never talked about. We know that when you mix calcium with CO3, you get CaCO3, which is a precipitate. It's a white precipitate that does not dissolve, right? It only dissolves in acid, but we don't care about the acid. So that's why when it forms a precipitate, it will be CaCO3. Or you could just look at the choices. Which one here forms a precipitate with Ca? Akid, it's just this one. None of these have Ca. Okay. انسى هلا رحنا على solution we added Ag. Okay, when you add silver, which one of them is a precipitate, which one of them is solution? We know AgCl is a white precipitate, فأكيد the precipitate will be AgCl. Which one would be solution? Ag. When you add Ag to NO3, you're gonna get AgNO3, which is just a solution. Before I start question 17, shout out to Muhammad from Doha. خلاص that's it. I minus here يا أخي, just match it with the precipitate. I minus, it's yellow. Ca, you get brick red flame أكيد. Zinc, it's white, right? You get white. Remember from cal, zone, كلهم they're white, but the one that characterizes zinc because it's the only one that dissolves in excess ammonia, NH3. But they don't really care. They're just saying, what's the color of the precipitate. Anyway, Zn2 plus white, Fe, since it's 2 plus, it's the green. Okay. Okay, here they're saying what would happen if you put each one in each one, right? So BaCl2, okay, you have chloride. Here, we're specifically talking about chloride. The only one to test for chloride is Ag. Here, معنا Ag, no precipitate. Here, these we don't care. AgNO3, it's a white precipitate, okay? Because when you add Ag with Cl, when you add AgNO3 to BaCl2, Ag will mix with the Cl, you're gonna get AgCl, which is a white precipitate. FeI3, it's gonna get a reddish brown precipitate when you add it with sodium hydroxide and NH3. Okay, Walid, طيب يا أخي, why reddish brown and not green? How am I supposed to know? Okay, like if they put green here. Look, نحن we know that Fe2 plus and Fe3 plus, right? We know this one is green, this one is brown. طيب, this one here, how do you know if it's 2 plus or 3 plus in this case? The subscript of I is the charge of Fe, right? So in this case it's 3. we know that 3 plus will be brown. For reddish brown. طيب, if you add it to AgNO3, some people, look, I was solving the quiz بسرعة and I put no precipitate because I said خلاص شو خاص Fe with AgNO3. Then I was like, after I got it wrong, I was like, oh shit, I with Ag, you get AgI, which is a yellow precipitate, right? Question 19. Okay, this is my, شكلي I erased it. Okay, so, again, sodium, it's with the big 5, it's soluble. PbSO4. Sulfate, over here, sulfate SO4, it's soluble except with BaCaPb, right? So sulfate with Pb, it's insoluble, right? FeS. Honestly, I don't know why, but I'm just memorizing. No, it's insoluble. I just memorized it. CaNO3, if it has nitrates, it's soluble. NH4, if it has ammonium, this is ammonium, not ammonia, because it's NH4. NH4 is ammonium. It's always soluble. CuCl, again, and I'm just memorizing it صراحة. Even though Cl, yeah, شكله if you have copper with chlorine, it's insoluble. Again, and I'm memorizing it according to my notes. These weren't written, I'm بحفظ. Okay, these ones are a bit annoying. 2021, 23. No, 2021, 22, 23, I think. They're asking you to write the net ionic. If there's nothing, put no reaction. Okay. Net ionic means precipitate is formed, and we said if precipitate is formed, that means it doesn't dissolve in water. Here, let's see. PB with, the first one with the last one, the second one with the first one. Okay, you get what I'm trying to say? Because, see, the PB here would probably mix with the I. Okay, let's see. I, would it dissolve with PB? PBI, would it dissolve? Let's go back to our notes. We said Cl, Br, and I, they will always dissolve except with Ag and PB. So that means PBI, it won't dissolve, right? طب نحن هلا we have a few steps. Actually, let's write. They're asking us to write the net ionic, يعني the equation. So you're gonna write PB, أكيد aqueous, plus I, which is كمان aqueous أكيد, to produce PBI. Now we have to make some changes. Okay, this is a solid because it's a precipitate. Don't forget the state symbols. Let's see. أول شيء, let's put the charges. Let's see. PB here is PB. Let's start. Yeah, sorry. PB, it's 2 plus. Well, how do you know it's 2 plus? Let's see. PB is 2 plus because the charge of PB would be the subscript of NO3, right? Crisscross, take it back up. It's 2 plus. Well, I, it's I minus. No, I think all of you know that the halides, fluorine, chlorine, bromine, and iodine, they're all minus. They're minus. So here, we're going to put 2 plus, we're going to put minus. So, okay, for the final one, is it correct to say PBI? No. We have to crisscross, right? You're going to get PBI2. So we're going to get PBI2. Am I done? No. Because here I have to balance. It has 2 here, have 1 here, so I have to put the 2. Okay, هلا, this is a full equation. Okay. For the second one, you have NH4Cl, it's mixed with CaNO3. Okay, أول شيء NH4, if you mix it, it's gonna combine with NO3. NH4 and NO3, you know, they're part of the big five, أكيد no precipitate. How about Cl with Ca? You know that chlorine is always soluble except with Pb and Ag. Do I have any Pb or Ag? No, so it will always be soluble in all the combinations here. So there will be no reaction. Okay. 21. All the next 3 questions كلهم هيك. Okay, same thing. I'm not going to read the question. Same thing. Any NO3 is mixed with KCl. Sodium will mix with Cl. If it has sodium, يعني no precipitate. We're done. NO3 is mixed with K. NO3 is part of the big 5. K is part of the big 5. And they'll always dissolve. يعني we're done. No precipitate, so no reaction. K3PO4. This one's a bit tricky here. K3PO4 is mixed with PbNO3. K with the NO3, أكيد they're part of the big 5, so they won't dissolve, right? So I'm not gonna cross over because you need it later. Then PO4 with PB. PO4, if you don't know what it is, they follow the same rules as SO4. Okay, well, SO4 always dissolves except when it's mixed with barium, lead, and I think silver. Oh no, calcium, yeah. So let me just double check this. Yeah, barium, calcium, Pb. Okay. So, it follows the same solubility rules as SO4. With solubility rules of SO4 is that it doesn't dissolve with Pb. So, أكيد PO4 now will not dissolve with Pb. So, I'm going to get a precipitate with Pb and PO4. Type. Let's write our reaction. We're going to write Pb plus PO4 to produce some sort of PbPO4. Right? We know this is always aqueous. Start with the state symbols because they're easy. The ions are always aqueous, with the precipitate is always solid. Okay. How do we want the charges? Pb, let's see. Pb takes the charge of the subscript of the second one, right? The subscript of the second one is 2, so its charge is 2. Which plus? Akid it's plus because it's the first element here. Okay, we're done from Pb. Halla PO4. PO4 takes the charge of the other one, right? And takes the charge of the subscript of the other element. And it's 3, so PO4 is 3 it's gonna be minus. Why minus? Because it's the second element. Okay. Let's see. Do we have to like, is it correct to just say PbPO4? No, we have to crisscross, right? You can't just say PbPO4. We have 2 plus, 3 minus. Crisscross, you're gonna get Pb3, PO4, 2. So the 2 goes outside, right? You have to put it outside. Okay, are we done? No. شو substitute balance. So عندك 3 هون, so you have to put a 3 here. عندك 2 هون, بتحط 2 here. 3 2 هيك خلصت. Okay, this is why I told you this one's a bit tricky, because you need to know that PO4 follows the same solubility rules as SO4. Here NaOH is mixed with AlCl3. Sodium, أكيد when you mix it with Cl, no precipitate, right? Precipitate. OH when it's mixed with Al, okay, is gonna form precipitate, because OH is always insoluble. Okay, OH and I think it was, what was the other one? OH and CO3. They're always insoluble except with the big five. Okay. Yeah, it's always insoluble. So when you mix OH with Al, it's gonna form something to do with Al and OH that isn't soluble, right? Actually, let's figure out the charge. You know, aqueous. Hone, whatever you get is gonna be a solid. Okay, let's figure out the charges of Al and OH. Let's see. Al here, it takes the charge of the subscript. So the subscript here is 3. So the charge is 3. So 3 plus. OH, it takes a charge here. OH, most of you should know it's minus. It's just minus. Okay? Since it's 1, it's just 1. Minus. Since it's minus, why is it minus? Because it's the second element, huh? Okay, and يعني انت لازم تكون حافظها. OH is minus, H is just plus. Anyway, crisscross, you're gonna get the 3 down here. AlOH, right? The 3 is gonna go down, so OH 3, and this just stays like this. Okay. Yeah, I guess this is it. Yeah. For part B, you again, same thing. It's made up of NH4 and CH3COO. بعدين عندك Na and OH. Okay. If you mix NH4 with OH, although the OH doesn't dissolve, it's still with NH4, which is part of the big five. Oh, you guys know the big five always dissolve. حتى if it's with OH, it's still gonna dissolve since it has the big five. بعدين CH3COO, when it mixes with Na, CH3COO is كمان part of the big five, it's always gonna dissolve. So that's why بنحط no reaction. 23. They want you to see the chemical formula of the precipitate. أول شي هون عندك copper mixed with OH. Will that form precipitate? Yes, because OH always forms a precipitate unless it's with the big five. So you're gonna have a precipitate with Cu and OH. Okay, and you want to know what's the formula of it? Cu and OH. You need to see the charges, right? The charge here of copper, since it takes the charge of it is the subscript of the second one, so it's gonna be 2 plus. Well, OH is always just minus, so it's gonna be CuOH 2 if you crisscross. Okay, we know that copper is always blue or pale blue. If you put blue, it's also correct. Here, Fe Br2 with NaOH. Again, when you mix this Fe with OH, you're gonna get a precipitate, because it's OH, you always get a precipitate. You have to crisscross to see the formula. You have minus and you have 2 plus, because the subscript is 2. Okay, if you crisscross, you're gonna get FeOH2. And you know, Fe2 plus gets you a green precipitate when you mix Fe with NaOH. NaI with AgNO3, you guys know obviously I with the Ag will get you AgI. Okay, and this AgI is 0. If you don't want to go through all this crisscross drama, or all this whatever, when you mix copper with NaOH, you always get COOH2. When you mix Fe with NaOH, sodium hydroxide, you're gonna get FeOH2. When you mix any iodine containing compound with AgNO3, you get AgI. And the color of these precipitates are straightforward. 24. Same question. Zinc with potassium hydroxide. Okay, it's gonna react with the OH to form a precipitate, right? So zinc which is, in this case, it's 2 plus, not 4, because SO4 is 2 minus, and zinc is 2 plus, so they cancel out, that's why there's no subscript. Okay, you should know zinc is 2 plus. Zinc is 2 plus, and it's going to react with OH minus, right? To get ZnOH2. These are all, by the way, in the Killenville reactions. If you go here, like zinc, it's gonna react, if you mix it with any OH or whatever, it's gonna react with OH to get ZnOH2. كلهم هون their reactions. Okay, CaCl2, the second one, with Na2CO3. This is a known reaction. We talked about it earlier. When you mix calcium with this, you're gonna get CaCO3, which is white. Okay, these are all white. Calcium, carbonate, calcium, zinc, calcium, and lead, they're all white. Okay, they're always white. These three. This one here, Na with NO3, أكيد no. So you're going to be Pb and Cl. So Pb and Cl, the charge of Pb is 2 because the subscript is 2. And Cl has no charge, so you're going to get PbCl2, which is a white precipitate. 25. Okay, glucose, which is this, is a molecular solid, obviously, and it dissolves in water, but it does not form ions. Okay, it's not an electrolyte. Okay, C6H12O6 gets you C6H12O6, but just dissolved in water, so it's an aqueous form. NaCl, sodium chloride, is akid ionic, we know it, and when it dissolves in water, it gets you ions Na plus and Cl minus. HCl is a molecular compound because it's metal, non-metal, and it dissolves in water to form H plus Cl minus. Remember that acids and bases, they form conducting solutions. They are electrolytes, so they are the exceptions for the molecular compounds. These are like the exceptions that form conducting solutions. That's why they form ions. So okay, these following 4 questions are about solubility. Just make sure you pay attention. When you increase temperature, solubility increases, but that's for a liquid. Okay, so solubility. Okay, I'm gonna explain it very fast. Solubility, liquid, gas. For liquid, increased temperature, increased solubility. For gas, increased pressure, increased solubility. If you want to kind of like understand this, if you're increasing pressure, that means you're squeezing something. So when you squeeze it so much, you're basically forcing the stuff to dissolve in whatever solution you have. You know what I mean? So if you have like مثلا an air solution, you put in it helium, He, whatever. Okay, but it's not dissolving. So what would you do? You would like compress it. You'd press it inwards, so you'd kind of like be forcing it to dissolve. You get what I mean? So again, for gas, if you increase pressure, you're increasing solubility. And if you're increasing pressure, that's the same as saying decreasing temperature. So decrease in temperature in this case would increase solubility. Okay, so liquid and gas is the opposite. For liquid, if you increase temperature, you increase solubility. But for gas, to increase solubility, you need to decrease temperature. Okay, so the solubility of a gas increases if you increase the pressure, but decreases when does it decrease? When you increase temperature. Okay, 27. I think 27 isn't. Yeah. Okay, yeah. Decreasing the pressure causes the solubility of CO2 in water to decrease. Okay, if you're decreasing the pressure, because we're talking about a gas, if you decrease pressure, that means you're decreasing solubility. So the solubility will decrease. But see, some people say, oh, but it's a liquid because you're saying in water. No, that's not how it works. We're talking about CO2 dissolving, not water. 28. I took graphs on. Which one here is independent of the temperature? In this graph, temperature is changing and the solubilities are changing. Which one is independent and which one doesn't care about the temperature? Okay, this one here because it's not changing as the temperature changes. Okay, so it's going to be substance A. Which one is a gas since its solubility decreases? Even let's say they didn't put this. Okay, you should be able to find out which one is a gas, which one's a liquid. Okay, let's erase this. Which one's a gas, which one's a liquid? We know with temperature. with temperature in a gas, if you increase the temperature as it's increasing now, we know that if you're increasing the temperature for gas, that means it should be decreasing solubility. Okay? In this case, which one, as temperature is increasing, it's going down, it's decreasing the solubility? It's this one, this orange one, so it's B. So B is a gas. Okay, وهنا كمان, in the exam, if they give you this hint, and they're basically giving you the question. But let's say they didn't give it. Which one's a liquid? We know that for liquids, as temperature increases, solubility will also increase. Which one goes up? It's the gray one, which is C. Okay. 29. To increase the rate of dissolving a salt, okay, salt is solid, right? Solid or liquid. The rules I wrote were solid/liquid. Okay. The temperature should be increased. Command the surface area should be increased by using smaller salt crystals. People say, "Shoot smaller. How is that increasing surface area, Amanda?" Remember, for surface area to increase surface area, you need to decrease the size of the whatever you have. Okay. Remember, this is the solid, huh? If you increase surface area, by the way, it makes it dissolve easier because there's more surface area. It's kind of like the rate of reaction. Okay, this one here, honestly, it's limiting excess. Do I think she's gonna bring it? Honestly, no. But don't take my word for it. Okay, please don't take my word for it. I don't think it do, but obviously you still have to do it. ماشي? If you remember, in grade 10, when we were doing these exercises, and they ended up saying that a precipitate was formed, that means you'd have to do limiting and excess. So you see this type of exercise, they say 5.5 milliliters of 0.5 molar concentration NaBr is added to 14.5 milliliters of 0.5 molar concentration AgNO3. Give the formula of the precipitate that forms. Part A, nice and easy. What is the formula of the precipitate that forms? You have NaBr and you have AgNO3. AgNO3, remember, is used to test ClBr I minus, right? Minus. Okay. Now what do we have here? We have Br. So okay, the Ag will mix with the Br. So you're gonna get AgBr. Now, what's the mass of the precipitate formed? Listen, they're saying maximum mass of the precipitate formed. If this comes in the periodic, if you're gonna follow the exact steps I do now, one by one. They're the necessary steps you have to write for a full mark in case it comes written. The necessary steps you need to get the correct answer. أول شيء, what I like to do, write the dissociation reaction of each one and find moles. Remember the steps from grade 10. Write dissociation reaction and find moles. After you find moles, write the net ionic. After you write the net ionic, you're going to find the limiting by doing n over coefficient. And the last one, after you find the limiting, cross multiply to find m of precipitate. Okay, let's see. Dissociation reaction and find moles. We have NaBr and AgNO3. Let's start with NaBr. NaBr dissociates to form Na plus akid. Everybody should have the charges memorized. Br minus. Group 1, group 7. You know, group 1 is always plus 1, and the group 7 is always minus 1. Right? Go open your periodic table if you don't believe me. AgNO3. AgNO3 dissociates to. You get it from another question, by the way. The charge will probably be written in any other question. Ag plus. Okay, start memorizing. NO3, we memorized it in grade 10. It's minus. Okay, we don't care about the state symbol, nothing. And we're just writing this, so we find moles. طب to find moles, you have volume and you have concentration. How do you find the moles? N equals C times V, right? So let's see. Here, for the first one, the concentration is 0.5. And then the volume is 5.5 milliliters. But what do we want? We want it in liters or decimeter cube, right? So we're going to divide by 1,000. Okay, and you're going to get 2.75 times 10 to the power of negative 3 moles. Mole. طيب هون Isn't it the same coefficient? They all have the same coefficient. What does this mean? It means they have the same moles. Okay, how about for the second one? We found moles for the first one. Okay, mole. Let's find now the moles of the second one. The second one, N equals CV. They gave us the volume, they gave us the concentration again. So let's see. Let me just write. This is volume, this is concentration. N equals CV. The concentration is 0.5 again. The volume is 14.5 milliliters, but like I said, we have to change it to dm cube or whatever. Yeah, to dm cube or liter by dividing by 1,000. I don't know why I like there. You're gonna get 7.25 times 10 to 7.25 times 10 to the power of negative 3 mole on command, since it has the same coefficient, right? On command 7.25 times 10 to the negative 3 mole. Okay, same coefficient كلهم same moles. Okay, هلا we found the moles. What's step 2? Write the net ionic. So هنكتب هون 1 هون 2. هلا هنكتب النت ionic. Net ionic, for those of you who don't know, is basically, we even though they asked you to find the net ionic equation in previous questions, the net ionic equation is the equation that only involves the precipitate and how you got it. Okay, so net ionic in this case would be Ag plus Br minus to produce AgBr. Okay, now in the written, you don't have to put state symbols, you don't have to put charges. What matters is the coefficients. Is it balanced? Yes, that's what matters. What do we know? Now we know that the moles of Ag, no, we wrote the net ionic. Now we want to find the limiting. We want to find the limiting, right? The limiting is by doing n over coefficient. So here we want to see, is Ag or Br the limiting? Let's see. Ag, the moles of Ag is 2.75. No, sorry. Is 2.7 is 7.25 times 10 to the power of negative 3 mole, right? What's its coefficient? 1. So you get it from the net ionic, not from the other one. Even though here it's the same, but in other questions maybe no. You get it from the net ionic. It's 1. So you get that the limiting reagent of it, the ratio of it is 7.25 times 10 to the power of negative 3. How about Br minus? Its moles is how much? 2.75 times 10 to the power of negative 3 mole, right? How much is its coefficient? 1. So you get 2.75 times 10 to the power of negative 3. Which one is smaller? Remember that the smaller is the limiting reagent, right? Which one is smaller? It's Br. So that means now we found our limiting reagent. What do? We cross multiply to find the mass of the precipitate. Let's see. Let's erase this. Okay. We want to cross multiply and do RR and GR, right? Let's see. So we did step 3. We found that Br is the limiting. Hello, for step 4, to cross multiply, we have Ag plus Br to get AgBr. RR, GR. نحن, what do we have? We have the moles of Br. In the reaction ratio, it's 1. How much do we have it? We have it as 2.75 times 10 to the negative 3. What are we trying to find? We're trying to find the mass of the precipitate. How much is the mass of AgBr originally? Originally, it's 108 plus 79.9, right? 108 plus 79.9, which is 187. Oh, no. Ya Allah. Okay, yeah. Saying it's 187.9. That's the mass of it in the reaction, right? Because it's 1 mole. هلا نحن what do we want? We're trying to find its new mass, right? So we put X for GR. You cross multiply and you're gonna get 187.9 times 2.75 times 10 to the power of negative 3. So we're going to multiply it by 2.75 times 10 to the power of negative 3. You can get 0.516725, which is 0.517 grams. Thank you so much for watching, and good luck.